Swinburne University of Technology.
In this video we are going to look at how to add loops to our R functions. So a loop is where we want R to perform a particular activity a certain number of times, and so it will loop, it will repeat however many times we specify. Two different loops that we're going to look at. One is called a for loop and one is called a while loop. There's some times where we might be doing vector and matrix operations where there could already be a built-in function in R. So things like the apply family can actually do things that otherwise we might do with loops. However, it's still important to know about loops. They are a fundamental part of programming. Okay, so I have a function here, and so adds numbers, and it's going to, we see my comment, returns the sum of the numbers from 1 to n. So we're going to give it a number, and we want it, we want this function to go 1 plus 2 plus 3 plus 4 plus 5, all of the way up to n. So we can see that I've started off with a total of 0, and then this bit here, this is the key bit, so 4, and then I have some sort of indicator, and I've said I. This is a fairly standard convention. If we had loops within each other, then each separate for loop that's within another one is going to need a different indicator. So we might have I, then j, then k, or something like that. And so it's saying we're going to have this indicator value I, and it's going to go from 1 up to whatever we specified n. And at each step, total is going to become the old total plus the value of I. So the first time through, it's going to be 0, and the value of I is going to be 1, so the new total will be 1. And then it's going to come and it's going to check, have we got up to n yet? So let's suppose that n was 5, it's going to say no, let's go through again. So my total is 1, I is now 2, it steps up by 1 increment each time, adds on 2, loops around. I is now 3, gets my total, adds on 3 to become new total, loops around. And then when it gets to the end, then it will give me, it will return my total. So I can use this value, so this could feed into something else. Okay, you can see one thing that I didn't do with this function, which is a little bit lazy, is I didn't error check. So I didn't check that n is a single digit. So someone could try and be clever and they could pass a vector or a string or something else, and we will just get a default error message saying, well, this function's not going to work like that. But we could build in our own error checking, so we could have some if statements saying, well, if someone passes a string, or if someone passes something that's not a single positive number, then we'll give it an error. So let's pass it down and add some numbers 1. So if we wanted the numbers from 1 to 10, numbers from 1 to 10 add up to 55, and we could check that quite quickly with some mental arithmetic. Seems pretty reasonable, and we can expand it out. Pick something a bit odd. And we can see that it just adds up numbers. It does it pretty quickly as well. So if we wanted, maybe we could actually assign, so x is going to be, add some numbers, and whatever we decided, maybe it was 23. And so we have a look, contents of x, there's the value that got returned. Okay, what we're going to do now is we are going to look, I've got a second function here, add some numbers to. It's going to do the same thing, but instead of using a for loop, it's going to use a while loop. So with our while loop, a while loop will operate while a particular condition is being met or not met. So our particular condition, while I is less than or equal to the value of n, then it will keep going round and round. So we can see we've still got the total equals total plus I. This time we've had to actually put in an I equals I plus 1, so we've had to put in a manual increment, so I will go 1, 2, 3, 4 until it gets up to the value of n. And total is going to keep growing, so it's going to do the same thing that it did before. still going to return. So it does a similar kind of thing. The thing we've got to really be careful with the while loop is that we have potential to end up with an infinite loop. If we set a condition for our while loop that will never be met, then it will just keep operating until we go and quit R. So with the for loop, we specify you start at this number and you end at this number. With the while loop, it keeps going until this particular criteria is met. So we need to be careful about infinite loops. The positive of using a while loop is that there is that additional flexibility. So it will keep going while a particular condition is being met or not met, and that gives us some more flexibility. Okay, so let's pass this down and add some numbers too, and give it a value, and give it another value. You can see it's giving us the same answers, which is good. Shows that I was able to program the same function with the for loop and the while loop. So for loops and while loops will often form a core part of your functions, because there will be things that you want to apply across data sets or to happen a certain number of times. As I said earlier, do try and be aware of when there is a more efficient way of doing things. So for instance, if I wanted to add up the numbers from 1 to n, I could use for loops and while loops, but I could check and see whether there is any built-in function, and perhaps if there is, it's going to do things at a system level, and it's going to be more faster and more efficient.
This has been a Swinburne production.